Alright folks, welcome back to the channel. Today we're going to go through Leetcode 242, which is Valid Anagram. And Valid Anagram is a Leetcode easy. We are going through the Neetcode 150 problems right now, so I got this problem from that list. So we are going through easy problems, but that being said, there are two ways to solve this problem. One is I'm going to go through the way I solved it, which is to me the most intuitive way, and then we're going to go through a more optimized way after that. So valid anagram is asking us to compare two strings. It's asking us to compare S and T to each other, and then if S is an anagram of T, it wants us to return true. And if T is not an anagram of S, then return false. And then Leetcode tells us what an anagram is. Down below, it's a word or phrase formed by rearranging the letters of a different word or phrase, typically using all the original letters exactly once. So in example 1, we have anagram and string T, which is nagaram. And so these both have three A's, and they both have an N, they have an R, they have a G, and an M. If we're comparing these two, they both have three A's and RGM, so now we can return true. And then for example 2, rat and car, so those are not anagrams because there is no T in car. So that returns false. So pretty straightforward. So when I first looked at this problem, what made most sense to me was to simply use the sorted keyword in Python. I already knew of this keyword and I knew what sorted did, but just to explain what sorted does, Python basically has this keyword, and most languages have it, if not all of them, where basically it will sort whatever array of numbers, or if you have a string, it will sort a string alphabetically. So that's nice. It will alphabetically or numerically sort whatever you pass into here in the sorted keyword. And what's good about that for this problem is that, as you can see here, when I was comparing in example 1, when I was comparing anagram to string S to string T, I started off by counting how many characters were in each word, and then seeing the occurrence of those characters. So using the sorted keyword in Python, we can basically sort S and T, and then we can get their arrangement of characters, like we have done right here. And then we can essentially take that array of sorted letters, and we can just compare the two to each other. We can ask if S is equal to T. So the way we would code that up, let me get rid of all this real quick. The way we'd code that up is pretty simple. So first we could have something like input 1 is equal to sorted S, and then input 2 is equal to sorted T. And just to make this clear, when we use the sorted keyword, what it's going to do is it's going to take, in the case of S, string S right here, it's going to take anagram and it's going to put it into an array. So it's going to go from anagram to something like this, and so forth, all the way for G, R, and M, and it's going to have everything in an array. So what we can do to make it easier to compare these two arrays is we can join them together using another keyword called join, which is pretty straightforward. And in Python, to join an array together, there are all these values together. We can join them with an empty character and then say join, and then put this in parentheses. So we can do the same thing for string T as well. dot join. So now we have our array of sorted characters organized together. And so continuing with our code, now we want to compare these two inputs together. But before we do that, there's one easy check we can do that we can implement to make sure that we are getting an anagram. If you look at, I'm actually going to create a new example here, example 3. Say you have cart and car. Say you have those two strings right here. This is S and T. One quick thing, oh wait, that's supposed to be car. There you go. Say we have these two strings. Basically, what we want to do a really quick check to see if these are anagrams of each other is compare the size of these strings. So we know right off the bat that S is not an anagram of T simply because of this extra T. There's just more letters in cart than in car. So to do a really quick check, before we even compare input 1 to input 2, we can see if they're equal in size. Sorry, I said that wrong. We want to compare input 1 to input 2, but we just want to check their size. So we can say if input 1 is not equal to input 2, return false. And then we want to now compare. So if they are the same size, then it's just going to continue. It's not going to return false. But if they are the same size, now we want to do our actual check. If they are the same size, if input 1 return true. And if not, we can return false. And that will give us the right answer. Okay, and now I'm going to talk about the time complexity of our sorted approach. So in Python, the sorted keyword uses an algorithm called timsort, which was made by a guy named Tim back in the early 2000s, which is a combination of merge sort and insert sort. And because of these two algorithms that timsort uses, when it comes to time complexity, the big O is always going to be n log n. And that is a best case and worst case scenario for timsort. I'm going to link below some more info on how timsort works, because I can make a whole nother video on what it is and how it runs. But just know for this video, we just need to know that it runs an O of n log n time because it's using a certain sorting algorithm. And then for time complexity, at worst, not time complexity, space complexity, at worst, it's going to use O of n time, and that's based on the size of our input array. And at our best case, it's going to use O of 1. And that's simply based on how structured our data is. When our data is very unstructured, it's not organized at all, it's going to have O of n time. And when data is very structured and it makes it easier to sort through, it's going to be O of 1. All right, so now we're going to look at the hashmap method of solving this problem. The reason we're going to use a hash map to solve this now is because a hash map is actually more optimized when solving valid anagram, and it's going to give us about the same space complexity, but it is going to give us a faster time complexity. So that's the reason we're going to use hash map. And so when we write the code for this, one important thing we need to do when setting up our hash map is we need to refer to our default dictionary. And to do that in Python, you just say hashmap is equal to default dict, and we set it equal to int. And the reason we do that is because Python will basically automatically create a key whenever we try and access the keys in our hash map, and it'll give it a default value if that key doesn't exist. And this is to prevent basically what's called a key error. So it's really important that we have default dict in there, simply because if we don't, um, Python's not going to know what value or what type to create the keys as. So that's the reason we're doing that and not just squiggly braces instead. Okay, so now that we have our hash map, the first thing we want to do is we want to count the frequency of our characters in string S. And to do that, it's very simple with a hash map. We can simply iterate through I in string S. So this is basically going for every character I in our string S, we want to add that key at hash map I, and we want to increase that counter by 1. So basically our hash map, because of our default tick, it knows that that value is going to be an integer, and for every character in S, it's going to increase the counter by 1. So for going back to example 1, we're going to have our key value hash map right here, and I'm going to draw the box out, and we're going to have a couple of squares, and we're going to have like an A, an N, a G, and so we had 3 A's. So this hash map is going to know, okay, for 0 in S, for value 0 in S, that's A, it's going to count. A is going to go up. So maybe it won't start at 3, it'll start at 0, but um, it will go up 1. And then when it gets to N, it'll go up 1. And when it gets to G, it'll go up. When it gets to A again, it'll go to 2. So now we have a for loop that's counting all the strings in S. So then we can do the same thing for string T, for I in T. We have hash map I, and instead of doing plus equals 1, that's the intuitive thing to do. But I found that instead of doing plus equals 1, we could actually do minus equals 1. And basically what it's going to do is it's actually going to decrease our value of 2, our value of n, our value of g, and it's going to bring everything back down to 0 instead. And now, whenever we write our final for loop comparing the values, we can write something like for character in hash map. And this time we're not looking at the keys, we're looking at the values. So we can use the values keyword here. So for every character in our hashmap.values, if the character is equal to 0, we can return false. And so just to explain this a little bit better, we're looking for every character value in our values part of the hash map, so this side. If it's equal to 0, we can return false. Or if it's not equal to 0, we can return false. And we're doing that simply because if this was equal to 1, then we know that there was one more A in string S than there was in string T. And then if this all passes, if we go through all this and we pass, we can return true. And so the time complexity here is a little bit more optimized. Time complexity is going to be O of n. And we know it's going to be O of n because we're only using a for loop once to iterate through our entire values column for our hash map. And n is equal to the total amount of characters in both strings. And our space complexity is also going to be O of n. And that's entirely dependent on how the data is arranged.